Welcome back to the SAS learning sessions. My name is Naga Vimprala. Today we are going to cover regular expressions using PERL. They are called as PERL regular expressions in SAS. We have so many functions in SAS. They are PRXPARSE, PRXMATCH, substring, and PRXPOSN for position, and PRXCHANGE. There are a couple more, but today we are going to cover basically these five PERL functions, PERL regular expression related functions. Out of these uh, five, first one, um, first one is the declaring the regular expression. Basically, we do some string manipulations or finding a string using these functions. Uh, the first three, the PRX parse, here we declare the regular expression what we are trying to identify or what we are trying to modify, and it returns a unique system generated. It will make the system to understand that regular expression which we are trying to identify within a string. So it is basically a pattern that is returned out of PRX parse. And these three functions what we have here, PRXMATCH is a function, and these two are call routines. Using a call, we can give, or even we can issue it as a function also. These three functions basically we use to identify a string pattern, and the final function PRXCHANGE, it is to replace any particular pattern with uh, whatever the string we need. Like we can replace special characters and replace it with a space. It is used for replacing the regular expression, replacing the pattern that we identify through the regular expression. So today I have taken couple of requirements. One is I have a sentence which you can see here. There are three sentences, and I am separating out the sentences with either hyphen or a quotation mark, single quotation mark. So like this sentence is a weird one having so many words. Okay, in this I have separated each word with hyphen or a single quotation mark, and my requirement here is to display each and every word into the log as a each and every word out of this sentence, which is separated by the hyphen or a single quote. We can do it in different ways, but as we are trying to learn Perl regular expression today, we will try to do it using regular expression. So for this, first let us generate the test input data set. It is created, no errors. Then first approach I am using it using I'm trying to execute using PRXMATCH. What PRXMATCH does is we have to pass the expression. Here I am capturing the return value into delimiter, find delimiter, or and find word. So whichever is followed by hyphen and a single quote, uh, I am capturing it to find delimiter, and a word followed by a single quotation mark or even more multiple quotation mark and a hyphen, that I am capturing into find word. So the pattern within these double quotes and the single forward slash, basically this is what our expression which we are trying to convey. Whatever the expression that I am giving here, it is similar to Unix Linux regular expressions. So there is not much difference, and there is another way to do this. Instead of giving lowercase a to z or lower uppercase a to z, and here in curly braces I am saying anything, any number of alphabets from 0 to more. followed by a hyphen or a single quotation mark. At least one should be there. Then I am capturing that kind of pattern into find word. If it is found, this will be set to the value. And here just the delimiter, either one or more delimiters which is of hyphen or a single quote. If it is found, this particular find delimiter will be set successful. So what I am trying to do here is I am doing a loop here. These are all just declare some statements. Overall the loop is whenever there is any delimiter, I am going through the loop and I am capturing each and every single word. So for that I am getting a substring. So what I am doing is uh, the position delimiter I am declaring, and the word delimiter I am declaring. So match, whenever we got a delimiter out of this sentence. So here the sentence is, this sentence is a weird word. So whenever we encounter a delimiter here, which will be the this particular location, we have this particular position at fifth position. So position delimiter will hold 5, and the word delimiter position word will hold 1, because the word delimiter says any number of alphabets followed by either a single hyphen or a single quotation mark. So it will be first character itself, and the position delimiter holds number numeric 5. So what I am retrieving here is word is equal to, from the sentence we are capturing from first character to position delimiter minus 1, which is 5 minus 1. So first four characters I am retrieving into word, and the new sentence, once I retrieve the word, I am again getting the new sentence, updated sentence with the rest of the words. So the sentence will be, again it will be from here. Sentence is a weird one again. So like that I am putting it in a loop till all the words are displayed. All the words are displayed using this put statement here. Once I am done with all the words and the last one, then I will go with there will be no more position delimiters, or the length of sentence it is equal to 0, because and the new length I am calculating here. uh, the new length I am calculating here, which is the length whatever it is. For example, if it is 50 characters minus the first time if it is found as 5, so 45 is the new length. So like that I am calculating the new length for each and every word once I retrieve the words. So once all the words are done, mostly it will be 0. So in that case my sentence itself is the final word. So once all the words are retrieved, I am just displaying it word by word. So let us run this piece of code. I got some 10 words, 7 words, and lastly one word in the spool or the log. Yeah, I am displaying all the 10 words here. This sentence is a weird one having so many words. Likewise, the second statement, yet another one created with alphabets alone. And final one, it doesn't have any hyphen or a single quote. This is a tilde symbol or a curly brace here and a colon greater than symbol. So we don't have any delimiters whatever we are giving in the PRX parse. We are not declaring anything in the PRX parse. So this is a expression. We call this particular value find delimiter as the expression which capture the return value from PRXPARSE function, which we are using it in the PRXMATCH. So we are using the regular expression here. So this is the first approach using PRXMATCH. Moving on, we are going with the second approach, which is using substring. And PRX substring, it holds lot of parameters. If you look at the syntax, the first expression, first one will be the regular expression ID or the regular expression itself, and source, which will be the sentence, and the third parameter holds the position of where the expression is found, and finally the length of expression that it is holding. So we are in previously using the PRX match, we were calculating this length manually by calculating delimiter and then word separately and doing the delimiter length minus the actual word length. So some calculation we have made here. If you look into this calculation, we are capturing it as position delimiter minus 1. That is, uh, till that position we are capturing the value. Like that we are doing the some substring. But here in this PRX substring, we already directly we are getting the position where it is starting and the length of that expression. It's a little easy. So let us look at how we are doing it in approach 2. First thing, I am declaring this regular expression. This time we are doing it a little different way. Instead of giving it as lowercase a to z, uppercase a to z, and those repetitions are more than one, I just directly declared it as word. This w plus is a special a message. We convey a special message using w plus, which stands for word in the regular expression. So we are giving it for we are following a backward slash followed by the w plus. Then only system understands that there is a special meaning behind w plus, which is for a word. So whenever a word is encountered, which usually holds lower alphabets or uppercase alphabets, followed by a hyphen or a single quote, at least one or more, that is when this find word will be set true. So substring, within this sentence, anything that is coming like that, we will be having a position and a length. So if the length of sentence is 0 and no delimiters are found, that whole sentence itself is going to be a word. So I am displaying this whole sentence. So the third one, which we don't have any in the third sentence, we don't have any hyphens or a single quote. So the entire sentence will be taken as a single word. So for this purpose, I have given this if block. Else the total number of words will be 0, and we will be getting those total number of words within this do while loop. Again, I opened a while loop, and the find word is a regular expression ID, and on sentence I am running this PRX substring. Initially we have seen this is a um, call utility, not a function, direct function. It's a call routine, and I'm capturing position and length out of this substring, PERL regular expression substring. So the same way, the new length I am capturing, because I have to cut each word by word. So whenever the length is more than 0, that means we have such kind of expression found. Then I am capturing the word length, which is length minus 1 in the same case how we have done in approach 1, and I am getting this word with from the sentence first one, from the first character to till the word length, which is 4 characters from the first sentence. Likewise, once I am done, I am incrementing the total number of words. Once for the first input, all the 10 words will be displayed. So this is using a call routine PRX substring. running this code now. These regular expression plays a key role whenever we have something like identifying a pattern or suppressing the special characters within the data or doing some massaging with the data. So it plays a crucial role in SAS. I got the output now. Sentence. We have 10 words here, 7 and 1. The same what we got in previous approach. The same way I'm displaying these words. First sentence, second sentence, and finally the third one. Third one is the whole sentence. Let us go with another approach using PRX position. So basically, uh, let us look into the syntax of PRX position also. This is again a call routine. So how we capture it is using a capture buffer. So whenever we find this expression ID, okay, we have to remember one thing before using PRX position. We can check whether there is any match on this expression or not. That means, for example, we have a hyphen and a single quote used in the whole sentence. If using PRX match, if any such kind of pattern is identified in the string, then we can run the position. What it will do is, if the capture buffer is given 0, then it will return the first starting position and the length of entire match. So we can retrieve the first position using capture buffer 0. So likewise we can loop through all the occurrences to retrieve each and every individual occurrence of the special pattern whatever we are looking for. So the syntax is capture buffer we have to mention, uh, and then the regular expression we have to give, and finally the start and length where exactly we are capturing the starting position and the length. It is again very easy. Syntax is a little easy, just four parameters it is passing. So what I am doing here is I am passing a capture buffer of 0 and running this regular expression id on sentence. So first occurrence I will be getting here. I am not using the length of it, but even we can make use of length column, but my purpose is very simple, so I just used the first occurrence itself. So what I am getting is, so I am running match. When the match is found, then only I am retrieving this PRXPOSN. I am running this one, and finally I'll get the word directly out of this position. It's a easy thing. Directly it will return the first occurrence, the whole pattern whatever I am looking for, it will be identified. So I just used a word pattern. So whatever is the delimiter, it will work. I don't need to you mention just a hyphen or a single quote. So what is going to happen is, as I just mentioned, word itself, even for this particular third sentence, it is going to work because the tilde symbol, the open brace, all these things are not considered as W plus character. Only this will be considered as uh, W plus W plus character. So here in POSN, PERL regular expression position, I have given the expression ID W plus alone. So whenever we encounter first few alphabets, that will be captured into word. So how I am looping is, again I am calculating the next position just by giving uh, what is that the pointer. I am incrementing the pointer to the next word, and I am capturing the new sentence, updated sentence. So again I am capturing the first matching value into word. So likewise I am displaying, I am incrementing simply and then displaying each and every word using a put statement. So if you run the code for all the three sentences in the input dataset strings, it should be displayed in log, basically 10 7, and here instead of one word we are getting 11 words this time. So this sentence is a weird one, having so many words. Like that, it displayed all the words individually, and for even for the last one, this sentence does not have any words as per the code. This is not the right statement this time, because we did not pass any delimiter as hyphen or a single quote. We just passed the expression as w plus, which is for all the alphabets. So we are able to parse even the special character, all kind of special characters we are able to parse. So that is the use of PRXPOSN, using the capture buffer. Whatever we are giving here, we are retrieving the corresponding match. And finally, let us look into the PRXChange. It is to manipulate the expression we are under the expression and replace characters we can mention together. We can do one thing. We can give this entire regular expression as some value here, like regex expression, regex expression equal to, and then we can give prx parse, and then mention this whole expression here and give the expression id, and do the same stuff, or we can simply, but here we have to mention the regex expression here instead of this particular value, or we can directly mention the expression. As we have seen this kind of approach previously, I am just giving the expression directly here, and I am replacing wherever we are finding hyphen or a single quote, I am replacing it with just a blank, and S stands for all the occurrences, and -1 stands for it has to be looked into the whole sentence itself. The regular expression will be applied not just for one occurrence, it will be for all the occurrences till the sentence is end completed. So let us look at the syntax. PRXChange. Again, this is a call routine, and the parameters are expression id, how many times we wanted to find. Here we are giving it as a -1, that is for the whole. It will be applicable for if the times is -1, then all the matching patterns are replaced. And then the old string, new string, here I am not giving all those things, just the I am applying on old string. So even we can mention the new string here. So instead of giving it as updated string here, we can just give it as call PRXChange and give the new string here, updated string. This works the same way. So let us look at it in a different way. So it is going to capture, the new string is going to be captured in updated string. So what I am going to get out of it is replace hyphens and single quotes with spaces. Yeah, neatly it will be displayed. This sentence is a weird one, like that. As I have mentioned, just the hyphens and single quote, the additional characters like tilde symbol, open brace, column, all these things are not replaced. If we mention all those characters here, like if I mention the tilde also here, so the tilde also will be replaced. Let us run it now. Tilde symbols are replaced here. If I want open parenthesis, all these things, all those things also we can give here. Open parenthesis, greater than, less than. We can do these kind of things in using some character functions like tran word. but there are some limitations, like how many wherever we wanted to apply this regex expression, this much feasibility and flexibility will not be there with those functions. So whenever we go with some complex string replacements or identifying a string and all, definitely we have to use uh, PERL regular expressions in SAS. So this will be really helpful, and a must it is really a must learn approach, must learn concept in SAS that one should know whenever we are working with data manipulation or data massaging. That's all for now. Thank you. Signing off.